This video is going to be about eyepieces. Now typically if your telescope comes with a couple of them, you'll get like a low power eyepiece such as a 25 millimeter, maybe 30 millimeter, and you'd get another one that is about half that number, say 10, 12, something like that, which would be double the power. So the larger the number on the eyepiece in millimeters, the less power it has. It has a longer focal length. As you can see, the lower power one here has a larger piece of glass in it. It gives you a larger area of the sky, and it's also brighter and typically easier to get a good sharp image. Now if you want to add another eyepiece after that, a lot of people want one that's higher power. So we've got say 25 and 10, and then you might go to 5 or 6 and double the power again. And here again, your piece of glass in here is smaller, so you're going to be getting a smaller area. So when you first begin your evening, it's usually a good idea to start with the low power eyepiece to find your object, because it's easier to find with the low power, and then gradually work your way up to the higher power eyepiece so that you have less frustration. Now some telescopes also come with a Barlow lens, which is just designed to double or triple the power of the eyepiece you have. So if you have, say, this 25 and you use a 2-power Barlow, it doubles the power, which is basically the same as what you got here. And it's almost as cheap, really it's about the same price most of the time, if you're going to add an eyepiece just to get another eyepiece than it is to get a Barlow. I think the main reason a lot of companies have this Barlow when you buy a kit is because people want to see high power numbers as a selling point, and that high power is not always that great. So one of the reasons why going to high power is not as good is your telescope, just depending on how large the diameter of the mirror or the lens is, say in a refractor, it's only capable of a certain amount of power and have a good quality image. You can always get higher power by using a higher power eyepiece, but it doesn't mean you'll get a better view. A standard rule of thumb is to about 50 power maximum per inch of telescope diameter. So if you buy a 4-inch diameter telescope, the maximum good usable power is usually around 200, and that is when the sky is real clear and steady, and also when the object is really high in the sky, because when it's low in the sky, you're going to get more turbulence, if you will. It's kind of like when you're watching a sunrise or a sunset. It can give you kind of a rainbow effect, and you just don't get a very good view. Now if your telescope is a little more expensive than some of the entry-level ones, it might have a 2-inch focuser. Now usually they still won't come with a 2-inch eyepiece, but you could buy one. So what they do is they'd maybe come with a 1 1/4, and it would have a 1 1/4 to 2-inch adapter that slides in the 2-inch focuser barrel, and then puts your 1 1/4 in. And then if you wanted to go out and buy a 2-inch eyepiece, which as you can see has a lot bigger glass and it's got a much larger barrel, 2-inch versus 1 1/4 there, you get a much wider view with the 2-inch. And while I'm thinking about this piece right here is actually called an extension tube, and I bought this because on one of my telescopes, when I bought a 2-inch eyepiece with a much lower power, I needed to get the eyepiece farther away from the focuser, so I had to add an extension tube so that I could actually put it in there and get it locked securely. Now there's also a minimum usable power to consider too, and that's usually around 4 times per inch. So if you had your 4-inch telescope, it might be around 16 power minimum. If you get too low, you can get kind of a poor image, and one thing that happens is what they call the exit pupil gets too big, and the light that's coming out of the eyepiece doesn't all go into the pupil of your eye. One way to explain that is if the pupil of your eye is as big as the diameter of this one right here, and the eyepiece is sending a focused beam of light as big around as this diameter, it won't all fit inside here, so some of the light's being wasted. So in that case, you'd still get an image and everything, but it just wouldn't be as good as if you had the proper eyepiece. If you had the proper eyepiece, all of that light would be coming into this smaller area, and then you would get a brighter image, which is really nice if you're looking at something faint that's hard to find. Some people also buy what's called an illuminated reticle eyepiece, and this is for centering objects. This has a little crosshair in it, and it's really nice if you have a go-to scope and you're trying to calibrate it. Let's say you go and find your first bright star you're looking at with your really low power eyepiece, and then gradually go to higher power and get it centered up in each one. And then you go to this one here and you actually center it right in the crosshair, and then you tell your computer or your hand control that you have found and centered the specific star you want. And that helps with make your go-to more accurate. It's also nice if you're using a camera. Let's say you've got a webcam or a little planetary camera and you want to center Jupiter in there. The imaging chip on those cameras is very tiny. So if you get it centered in the crosshair here, pull out the eyepiece and then put your camera in, there's a much better chance that that planet is going to actually be in the field of view, and it makes it easier to find. And then if you happen to lose the planet, say if something goes wrong, you can go through the same routine, get it centered back in here, and then put the camera back in. It can save you a lot of frustration. Okay, now people usually want to know how much power each eyepiece is, and to figure that out, you take the focal length of your telescope and you divide it by the focal length of your eyepiece. So if you have a short telescope like this little guy right here, say you have a short telescope like this one here, this is only 350 millimeters. If I put this 25 power eyepiece in here, 350 divided by 25 happens to be 14, so that's a 14 power eyepiece. And then if I put a 10 millimeter eyepiece, 350 divided by 10 gives you 35 power. So you just need to know the focal length of your telescope, which it'll be in your information, and it's usually, some telescopes have it marked on here. Like this one says D 60 millimeter, that's the diameter of the glass here, the big one. And then the focal length is 350 millimeters, so that's just the overall length from the glass to the eyepiece where you're focused. And then it'll also, like this one here says f5.6, that's the f ratio of this telescope. So that's 350 millimeter focal length divided by the diameter of 60 gives you f5.6. Now if you had a much longer telescope, say you had a 4-inch f10 refractor, that would be, the 4 inches is 100 millimeters in diameter. f10 would mean that it's 1,000 millimeters in length, so you'd have 1,000 millimeter focal length divided by the 100 millimeter diameter, and it would give you f10.